What's up, all my YouTube fans? All right, maybe not fans. You're probably only watching this because you have to, but maybe you're watching it because you want to. I don't know. I've heard some people say that my intros can be a little cringy, and I'm not sure if you guys realize, but that's kind of the whole point. As a math teacher, I think it's part of our job to be cringy, and the cringier the better, I feel. At least I'm just going to keep doing it. So whether you think I'm cringe or not, I don't really care. So anyway, we are going to continue on in this section with proportional relationships. So with these proportional relationships, you should be able to understand and interpret proportional relationships using tables, graphs, words, or equations. Now the equation, and you might want to underline this, this is on page 182 in your books, page 182. But the equation is y equals mx. So any proportional relationship that we're going to look at is in this form. And m actually is the slope or the unit rate, or our constant of proportionality, or our constant rate of change. There's all these terms we can use for this value here. In the table, the slope is the constant rate of change or unit rate in a graph. The unit rate or slope is the constant rate of change or the constant ratio y over x. You can also find the unit rate from the point 1r, where r is the unit rate. So we're going to look at all these examples. If this doesn't make sense yet, that's okay. We're going to go through some stuff. So here's an example of words. The cost y is directly proportional to the number of breakfasts x. So whenever you see this directly proportional, that means it's proportional. We can write an equation like this to represent the relationship between y and x. So directly proportional means there's some constant m that we can directly relate y and x using that constant. So an equation might look like this, and a table might look like this. For every breakfast we add $2 to our cost. And again, the graph is a dashed line because you can't have half a breakfast. So that's why this line is dashed, because only these points actually work on the graph. But for every breakfast eaten, the cost goes up $2. $2 of cost for every breakfast, $2 of cost for every breakfast. So these are all the different ways you should be able to represent a proportional relationship. The graph, the equation, in words, with a table. So let's just look at an example. This example is looking at a rabbit and a grizzly bear, and the speed of a rabbit and a grizzly bear. So the distance in miles that can be covered by a rabbit is represented by this equation, y equals 35x. The distance in miles that can be covered by a grizzly bear is shown on the graph. So this equation represents the speed of the rabbit. This graph represents the speed of the bear. Two different representations, but from each of these we can figure out the speed of each of these animals. So let's first look at the rabbit. The speed is the unit rate or the slope or the constant of proportionality. All those things are the same thing. So in this equation, 35 is our slope or our unit rate. So the unit rate is 35 miles per hour, and this is on page 183, so you can fill this in the blank on page 183. Our unit rate is 35 miles per hour. So that's the speed of the rabbit. Now for the grizzly bear, there are several ways we can find the slope of this line, or the unit rate, which is the same thing, okay? So the first thing we can do is pick any 2 points on this graph. So let's pick these 2 points and find the rate of change between the points. The rate of change is the change in the miles, the y variable, over the change in hours, the x variable. So between any 2 points, the difference in the y is 30, and the difference in the x is 1. So the speed of the bear is 30 miles per hour. Or another way you can do this is just y over x, distance over time. So for any point, 30 over 1, 60 over 2, you're going to get the exact same thing when it's a proportional relationship only. This only works for proportional relationships. Or we can just take this point 130. So anytime the x is 1, the y value will be your unit rate or your constant of proportionality or your constant rate of change or your slope, all of those are the exact same thing. So the grizzly bear's speed is 30 miles per hour. And so again, if the rabbit is 35 and the grizzly bear is 30, then the rabbit is the faster animal. Okay, so let's look at one final example for this section. And actually, why don't you guys take a second and do the check problem on the bottom of page 184. So see if you can figure out which animal has a faster heart rate on that check problem, and we'll check that in class tomorrow. And now that you've paused and done that, let's look at this last example. So now we have a proportional relationship. The cost for computer repairs at Computer Access is shown in the table. So here's another representation. The last problem we had an equation and a graph. We can also use a table to represent a proportional relationship. So he charges $23.50 an hour. Assume that the cost is proportional to the number of hours. Which company, so here's, so this is the Computer Access, and then this guy, Macro Repair, charges $23.50 per hour. So which company has the lower repair cost? And this is on page 185, so you can fill this in on page 185. Well, if we look at the unit cost for Computer Access, which is the one with the chart, okay, we can find the change in cost, which is $25. It goes, if you notice, it goes up. For every 1 hour we go up, our price goes up $25. So our change in cost is $25 and our change in hours is 1 hour. So as the cost increases, and this is on page 185, you can fill in these blanks. As the cost increases by $25, the number of hours increases by 1, so the unit rate is $25 per hour. Okay. Oops, didn't want to go that far. Wrong button. So let's go back here. So the unit cost, for this company was $25 per hour. We can also, no, there should be another, let's see. Okay, there's no next button here. We know we are given the unit cost for this company. We're just told outright that they charge $23 per hour. So since 23 is less than 25, then Macro Repair has the lowest cost. But, oh no, that's, okay. Yeah, that was step 2. Sorry, I was reading that wrong. So again, all you're really doing, and we can look at one more example quickly, all we're really doing is, from all these different representations, being able to find that slope or that unit rate. So if Mason and Connor are kite surfing, the height of Mason's kite is represented by this equation. Connor's kite is represented by this table. Assume the height is proportional to the number of seconds whose person's kite increased faster. So this person's kite increased by 3.5 feet per second, whereas his goes up for every 2 seconds. His goes up by 4. So his unit rate would actually be 4 over 2, which is just 2. So Mason's kite actually increases at a faster rate. If you look, the change in the height is 4. It goes up 4, up 4. This goes up 2, up 2. So 4 divided by 2 is just 2. So the unit rate here is 2. The unit rate here is 3.5. So his unit rate is higher. His is increasing at a faster rate. Okay, so try the check problem on page 186. I will be looking for both of those check problems in the box on page 186. Draw yourself skiing down a slope. So do your best. It's probably going to be a stick figure like mine, but some of you might have something better. So in the box on page 186, show me a picture of you skiing down a slope. And that's where we'll end it for today. Have a good rest of your day, guys.